the chain, the block chain. So from the previous slide, we have two transactions with one signature. The second transaction, we have the same signature. What if we add this signature of the first block and add it to the second? So here I can achieve that. So I get to the second block, this signature should change, right? Because I added to my block. If we go back again, the block. Now I will add this signature to the block 2. Yes.
And what is the point to add the signature of the first block to the second block?
How we can do the chaining? This is the way that we are doing the chain to secure our network. Because if you have these three transactions, if anyone changes the signature of any of these blocks, the sequence block will be invalid, right?
Because the first hash function is the address of the second block. It's like an address. It's not like a data.
No. It's not like data. This is the cryptographic hash of the first block.
Okay.
You got the idea? If I change this code, if I change the signature, right? But this block already exists, which means any change on this signature digit, it will give me a different signature, which means this signature will be invalid as well, because I have to pass here a new signature.
What prevents that all the subsequent signature will be changed?
Because the same.
Yeah, definitely. There is a validation. Each transaction submitted to the network, it has to be verified. Against what I'll answer this question in the coming slide. However, to understand these, here, how to block, how to protect your chain. But as of now, I need to understand that each block, this is the mechanism of blockchain. Each block has a reference for the previous block. If you remember in the definition, one of the criteria we have a reference to the previous block.
What about the first block?
Genesis block. Genesis block, it's like the initiated block, the first one. It might be any data, and this hash will be passed to the second block. However, it's subject to your decision to create your Genesis block.
All this block is stored distributed in a lot of servers or
Yes. Each transaction, once one node, one computer send one transaction or one block to the network, all the network will receive this block and start verifying the hash or the signature.
Each block is the single unique object, or is something like object program?
Don't think about object. Grouping of sum of transactions. Logical grouping. It's not it's like an array of transactions.
No, because we define here block 1, block 2. Block 1 is a record or sum of records or?
Yes, sum of records, sum of transactions.
Okay.
It's not like, yes, sum of records, or these records are transactions. Maybe financial transactions.
Why we define it as a block 1?
Not with each transaction you will submit it. It's grouping the transaction in one block. Okay?
It is related to some processing if we are going to
subject to your business. Because, for example, in the cryptocurrency, for Bitcoin, for example, each 10 minutes it's submitting one block. One block, it has many transactions. Okay? And the whole block start getting verified. If you want to do a financial transaction, you have to have two records, debit and credit, right? You can't submit bit only without credit. Otherwise it will be invalid. Where this money goes to and from who? This is the debit and credit, the source and the destination, right? So at least you have to have two records to represent one transaction, for example. Like this one. Omar get 50. Get 50 from whom? From Ali. Ali now minus 50. So I can understand that Ali gave the 50 coins to Omar. You got what I mean?
Is there any specific name for the signature of the first block that embedded or embedded in the second block? I mean, just to distinguish that between this signature and the transactions.
Okay, the question is, do we have any like a description to this signature? No, actually the signature here based on the block 1 context. Whatever data you are having or grouping in one block or in the first block, accordingly you will give a signature. You will get a signature.
I think we asked about what's the key to know what is the signature of the previous block. Is there a key linked with the hash of the previous?
No. I'm using the first block is passing the signature to the second block. Okay, so this is the reference as you can see here. Maybe I don't understand the question.
So it's the signature of the previous block.
Yes, the signature of the previous block. So any change in this block, it will make the signature invalid.
What if Ali give Omar? Ali give Omar more $50. Same block again. So same signature.
It's not an issue. By the way, I'm not verifying.
This signature is not unique.
It will be different. No, it's not unique. As I told you, it's subject to the transaction that you have or the data that you have in the block. You got what I mean? So you might have 50 transactions, or 2 transactions, or 30 transactions. Whatever signature compiled here, it will be used in the second block, regardless how many transactions.
No, my signature is not unique.
No, it's not. By the way, wait.
Ahmed, I think he asked about how updating.
No, there is no. By the way, no. Once I create the block, it's immutable, as we said in the previous slide. You can't update the block 1 once it's submitted to the transaction, to the network.
Just created or just approved? Because
Once approved by the network, you will not be able to change it.
The idea is the signature isn't unique. Okay, the signature isn't.
No, the signature is unique. Definitely, the signature is unique.
The same signature will be found in the network. It will be new. I can't set it now because it already exists. This is the idea. هو is the signature is point to the previous block. Okay, signature point to the previous block. Okay, let's assume now we generate signature in signature, and this signature is the second one. If you try to enter into the network, okay, it will be block 4, but block 4 actually block 2 point to block 1. It will give you a can't accept that this signature isn't correct. This is the idea.
I mean, okay. The hash key is based on the transaction.
Exactly. Yes.
We have the same transaction twice.
Here,
Yes,
in
same.
this block.
Omar and Ali
Yes.
make 2 transactions
Okay.
for 50 riyal.
Okay.
Same.
Okay.
Same.
No, different.
The timestamp.
Timestamp is the
It's
idea.
different timestamp, other criteria. Okay.
The timestamp is.
By the way, we have the timestamp
Yes.
appended, one of the factors of the signature. So guarantee that the signature will unique across the whole network. Okay.
Excuse me, also, it's not about the transaction content, it's about the transaction itself, no matter the content, right?
Yes, it's like a transaction,
Yeah.
regardless what is the content. But still, he's using the content to compile the signature or generate the signature. Okay.
Well, actually, in Bitcoin data mining, what we are trying is generate signatures.
We'll
If
get-
it is
yes,
not valid,
exactly.
it will try to generate another signature and so on.
We'll get to this point. Yes.
There is a very good video in the YouTube or link also for blockchain demo to present this idea very clear.
You can share it in group, please, on the WhatsApp. You are a member in the WhatsApp group? Okay, please.
No, I'm not. But
The meetup, you have a meetup, you are in the meetup group, I'll send it there. It will be beneficial for everybody. Okay, do we understand this part? It's clear? Yes.
I'm assuming there is only one chain, right? We have one Genesis block. And
Genesis
one
block, yes.
Referring to the.
Yes, it's only one
So
chain, yes.
I think it's one chain.
Yeah, we are talking about, because all the parties involved in the blockchain, they are one chain, one blockchain. Sorry, there is a question, please?
And with the decentralized, is any implication over on the implementation?
Okay, yes, we will come to this one, yes. Okay, any other questions?
who's submitting the block?
Now,
Who's creating the block?
one of the peers in the network.
Anyone in the network?
Anyone in the network can submit a transaction. Still, don't think about Bitcoin and how it works, bit by bit. Okay. Like this clear. We have blocks and the chain. Data, any transaction. Blocks, group of transactions. Chain, reference from the first the sequence block to the previous block using signature. Okay.
Excuse me. Can we say the blockchain is a database? Let's say I have a database that I create a table and I put the column in that table, it's data and hash and the previous hash.
You can't say that blockchain is a database. You might use a file system. You might use a file system, not a database, not necessary. Again, we are talking about the concept, regardless of the technology you are using to fulfill the blockchain scenarios. Okay, you can create your own blockchain. You can create it in Java, one project in Java, some arrays, and you have some, and you dump this in a file system. No need to have a transaction, a database, for example. Okay. However, definitely one of the use cases to use a database, and each peer will manage his own data on a database. It's not an issue.
What about the computers? You say the data is distributed. Can I see the details of this data?
Yes.
Or just the hash?
Yes. No. You can see all the transactions. So we have two types of implementation on the blockchain area. We have like the hyperfabric. We will come into this point, and the Ethereum. Some has a public and some are private, so you can have it.
One of the main difference between blockchain and cryptocurrency is open ledger. Open ledger, anyone in the network can see the whole ledger, what happened, all the things. So this is the main difference between both. So
these are the transparency. Yes, one of the characteristics is the transparency. Whoever submit a transaction to the network, the whole network able to see these transactions. So you can trust each other. Because blockchain, it might be between some parties or different parties that they don't know each other. Like the supply chain. Okay, you are a car manufacturer. You need lots and lots of logistics stuff, materials. You don't know what this factory or this like warehouse is doing from his side. However, I need to have like the mutual or the transparency between my transaction and his transaction in terms of our engagement. I need this part, so I will send you the money, you will send me the part. That's it. I don't know you, I don't trust you. However, at the end, my records should match your records. That's it. Okay? Is it clear? Okay, sure.
I want to confirm that each implementation has its own chain. There is no shared chain. If I have an implementation on something like banking service, I think I have my own chain, not shared. Right? There's not a single chain for all implementation.
In terms of the implementation, you have one chain with different peers. For example, torrent. Everybody knows torrent, right? It's a peer-to-peer network. This is like the same implementation. Blockchain is utilizing the same concept. You don't need to have a centralized authority to run the whole network. You will have the contents at any peer, at any node, and you can copy and paste from it, right? You can exchange information. This is the same concept. But it's, again, torrent, it's only one network. It's fulfilled this business.
One more thing is, blockchain also it's a concept, so you can create your domain. The domain is, for example, in banking, so I will have Russian banking in my bank and one third bank, so we have our own domains. No one else will see what we are doing, and we will implement the blockchain for that domain, our only chain for our specific domain. So it is applicable to have your own chain.
Yes. And they will come, by the way, for the use cases in different sectors. Okay? Yeah. These two links, you can use it to get the hash generator. You can pass any data, and it will give you the equivalent hash cryptography. Okay? We clear so far? Any questions? Okay, good. Okay, how I gonna protect my block? Okay, anyone can alter the contents of the block, and he can submit it to the network for approval and pass on this and add the my block to the existing block. Okay. How do signatures stop someone from inserting a new signature for each block after altering one? As we said, altering one block, we have to alter the sequence, the following blocks, right? How the signature will prevent that? As we said, I think it's small, but I just need to prove the concept. If I have here the signature, and I change I give a different signature here, I alter these data, it will give a different signature here. Accordingly, this signature will change, and in the subsequent blocks, all will be invalid. Correct? How I can prevent that? Only hashes, signatures, that meet certain requirements are accepted on the blockchain. Okay. Who understands this statement? Right. Anyone can explain this statement? As long as you understand it.
But the hash, in order actually to alter the hash function for block 2, okay, the whole network must verify this alteration, okay? I mean that I can easily say that this block is altered by getting the signature of the previous block and comparing both.
Again, what are the criteria?
It should be unique.
I change the current block and I send it to the network. I'm attacker, outsider. I know because I have copy of the generic, the whole content of the transactions. As we said, it's distributed, right? So I have a copy, you have a copy from the same transactions. And for the last transaction, I'll add to my account $1 million and I'll submit it to the network. What is preventing me of doing this? Here, let's explain it in this way. These are the network fields, right? I have block 20, right? This is the last block in the network. Okay? In the block 21, I will add one transaction because still no one submitted block 21 yet to the network. I will do this and I will add some back transaction. I will add it to the network and send it to the network. By the way, I have the last signature of B20 because I have B20.
Is it the strength of the blockchain? You cannot trace the chain itself.
Here you are not changing the chain, you are adding one more, but again, the one who is submitting or the balance of this transaction is available in all systems. So
How they can verify that and say block 21? Regardless, financial, whatever transaction inside. I'm just giving you like the financial transaction because it's a sort of transaction. Again, if you remember in our example, we are not focusing on the contents of the data. We don't focus on this. We are focusing only on the content, not the nature of the content.
The content is shared between two parties.
At the end, the content is a set of characters and letters, right?
You can add some complex in the data, or let's say in the signature. For example, the signature will start by 2 zeros or 3 zeros, something.
Oh, you just saw it in the okay. This is okay. Yes.
It seems there is one program to generate hash.
There is one requirement on how this signature should look like, because I can generate any signature. Whatever that I'll submit, I'll get a signature out of it, right? However, all the network has to have a fixed format of the signature. Okay? For example, I need to add maybe zeros or a fixed digits to my signature to be able to accept this transaction. So we as a network, we agree on a secret key between each other, Okay, so whoever will submit the transaction, he has to fulfill this pattern. This called nonce. Nonce, it's like a number, it's a random number. Be chosen so that generated hash ends or start with number of consecutive zeros. Which means my signature here, this is for example, it must start with maybe 10 zeros. So any block will be submitted on the network its signature has to start with 10 zeros.
What is it? We can tell us in the next
This is he will not put he will not manually append zeros. The signature coming out of all these data inside this block has to start with 10 zeros or 5 zeros or 3 zeros. This is not an easy, because it's not a way of appending zeros. You need to add these contents, and the result, the generated signature, has to be zeros. For example, let's make it more clear. Okay, if I have here like the hash generator. Okay, I'll transaction 1, transaction 2, for example. Okay, I need to generate the hash. Can you see it? Clear?
Yes.
Clear, huh? Okay. So within my network, I need, instead of having these characters like this, I need to have like 5 zeros. How I can reach this signature? I have to alter these data to be able to get the first zeros, because anyone from the network will start getting this signature, it will not match the data, and the vice versa. Correct?
Similar to book 4.
This is the point. So if I have only the data, it will give me the signature, the original signature. Okay? So anyone in the network has to start trying to add a random data or a random string or a number to be able to generate one signature start with 5 zeros or 10 zeros. This is actually what is happening in Bitcoin. They are trying, all the miners or all the nodes in the network is trying to resolve this and find the nonce, trying to find this value. It will be clear here, more clear here. If I have this block, the block 1, it has 2 transactions, right? Okay, and it has this signature, normal, correct? Here I'll get a random nonce. I'll add it to the block 1. This is a random number. What will happen? It will give me a new signature with start with 5 zeros. Again, back. I have this block with some data. The hash of the content of block 1 is this signature. Clear?
Okay, so the nonce, I will select a nonce which can be appended with any data and give me 50 as a first.
Exactly.
With this data.
With this data, exactly, because it will be different. As long as the data is different, the nonce will be different. Because I need the nonce, once I put this random string, it must give me this signature. Start with 5 zeros. It's a trial and error, by the way.
From the outsiders.
Exactly.
But you trust the nodes in your network because all the node knows how to generate it.
No, because the content with each block is different, which means each random number will be different. You got it? For example, this block, give me a signature of A1, for example, as a signature. How I can append another string with A1 to give me 0000 A1.
For a valid transaction.
Still, you can decide it's a valid or not.
So about now, let's assume that we have a valid transaction, we need to go through the network. Okay, how this happens?
After submitting this transaction to the network, okay, the nodes is not there.
Okay.
The nodes is not there. All the network, all the nodes connected to the network is trying to find the right nodes.
All the nodes together.
All the nodes is trying to find this one. This is the mining. This is currently what you are getting incentive in the blockchain. Once you find the nodes, so you will be able to find this signature, which means you are the winner. So it will give you like 1 Bitcoin, whatever, about what is relevant to your share on solving or getting the nodes.
Okay, this is answer my question actually.
Exactly.
Each node knows how to generate this.
No, definitely it
Yes.
will be easy. Anyone can hack it.
Yes.
Okay, but the problem is that the contents every time is different. With each transaction is different, because as we said, it has transaction plus timetable, timestamp plus some metadata. Each block. So each block contents it's different than the sequence one. Okay, the next one is different, which means the signature is different.
So in mean of Bitcoin, right, each block has multiple transactions. So the nodes will be changed.
It will be
and
definitely
mining power will end.
The mining here, because as I told you, it's a trial and error. He's trying to get these data and try to add a nonce, a random nonce. Okay, whether it's giving me this pattern or not. The 5 zeros, starting with 5 zeros. No, it's not. So I have to use another nonce. Okay? This is what are the mining. How the mining is doing in Bitcoin.
And this process is very complex.
Yeah, definitely. It's very complex because it's not easy. It's based on the pattern, the number of zeros that you need, that you have.
But which means that this operation is challenging also for the network itself. It doesn't mean that
Yes.
I need to have a bad guy in.
No. This is a verification. It happens by all means. This is a verification step. Again, don't think about the implementation. Think about the technology and mechanism. Okay? Don't think about how, because in the business network you don't need to do this approach. I am a supply chain. I am a bank. I don't need to have this. This only applied maybe for the cryptocurrency.
Because
what
the
I
bank
mean?
is the only responsible for verifying the transaction, right?
Yes.
So, okay, what is the issue if I have a Thunder data? Okay, خلاص I will go through this try and error operation until I reach the random number that will give me this 5 zeros. Why the data is already wrong? What is the issue?
No. Again.
And now in block 2, okay, you added false data.
Okay.
Okay, and then خلاص this random nonce we will try to go through the try and error operation until we reach the random nonce that will give this hash that starts to 5 zeros.
If the data is wrong, you will not be able to add this to have the right nonce.
How can we verify this wrong data? No, that is the question.
Excuse me, Miss.
In this way, we don't verify the data because we are trying to.
No. You are verifying the contents. If it's different, the same data, it's different.
But when you add block and lost, okay, so is a new data, not the same data.
No. It's not the same data. You have in the peer time you have verification, because there is, by the way, guys, there is another aspect here. The consensus. The consensus concept will come. Okay, we'll come it later. But however, I need to understand to give you a clue about it. All the transactions submitted into the network, it has to have approved by a certain amount of nodes. Okay, so these how they are doing this verification. They are verifying the data or the signature of the data plus the contents of the data to judge whether this is a valid transaction or not. Okay, this is the consensus process. And the consensus process, it's taking this name from the consensus algorithm. The consensus algorithm, you are defining a set of nodes in your network to approve these data. I will say, okay, you might have the first row. These are my approver in the network. Everybody in this session, he is member of the network. However, only the selected nodes will approve the network. Okay, verify the network. Regardless about what. This will come up to open another topic, which is the smart contract. When exactly I will explain based on some rules.
The smart contract, when the contract is shared between two parties, it must be approved by the two parties.
Exactly.
Then I can understand
It will
that
be
another
submitted
application to the network.
to submit it. Yes,
But,
exactly.
Yeah, it's clear now, but to be this is the first step, it doesn't make sense somehow.
Now, sequence block slides it will explain more. Okay. Type.
What if I somehow try to manage the hashing algorithm without finding the right nonce?
It's not easy. How?
I mean,
That's why they are using 256 hashing. It's very complicated. Maybe trillions of people are maybe spending months or years to get the right nonce based on the obligation on the network. How many zeros that you need to append or appear in your signature to be a valid transaction.
So step one in verifying whether the hash is correct or not is they will try to trace it back and get the content.
Get the nonce itself.
Nonce itself.
The nonce it's using, it's random for each block.
Sorry, one second. Yes, definitely it will.
If you have two nodes very close to each other, like for example, one and two, it will produce totally
different signature, different cryptography.
Yeah, you can't see the...
No, as I shown the example, if you change any character, maybe caps from lowercase to uppercase, the hashing signature will be different, completely different. Questions?
This means that any member in that chain will not be able to insert a new block or transaction until they do the mining and produce this nonce again.
It must be approved by the network. Yes.
So they are not approved members.
Anyone can submit a transaction or a block. However, it's subject to the approval based on your rules on the network.
Either they are members or a newcomers, right?
At the end, he's a member. Even as a newcomer, because the newcomer, once he joins the network, he has to replicate the whole ledger in his node. Even here, now in the Bitcoin, if you want to join the Bitcoin, you will start first download the ledger in your node, because you will be part of the network. You will be part of the certification, the verification of the transactions, I mean. Okay?
Do you mean now if I want to transfer Bitcoin between me and you, the transaction will submit it after 10 minutes?
Yes, each 10 minutes there is one block submitted to the network. Yes.
And before that 10 minutes you cannot use this Bitcoin?
No, you can't. It will not be in your wallet.
For each block.
Is all nodes in the...
Sorry, he's trying to ask.
For each block, a random nonce generated?
Yes, based on because the content is different. At least on the timestamp it's different for each block. So you have to have a new random nonce. You will not be able to reuse one of them. No way. Impossible.
All nodes in the blockchain network are equal, or there are some nodes, nominated nodes that have more power or some additional?
Additional in terms of the approval. You might select some nodes and elevate them or give a permission for these nodes to approve the transaction. The rest will be like a normal node. They will get the transaction, they might submit a transaction, but they are not verified. Okay? Questions? Okay. The next step, I will use the same, it's the same mechanism. I will use the same signature in the next block, and I will get a random nonce. Now it's getting more complicated because I have more data here. So my digital signature of the previous block is part again of the block 2. And it will give me like the valid hash. The third here. Okay. Hash needs to start with at least 5 consecutive zeros. Okay, so I need here a random nonce, okay, to combine with all these data, and the result must start with 5 zeros. So people here keep trying. People here try to do mining to get the correct nonce, which will give me the right signature, which starts with 5 zeros. Okay, This is the mining part. I'll go to this site. It will give you more visibility. For example, this is one of the blockchain. Here, as I told you, this is the Genesis block, which is the first block in the blockchain. Okay, it has some data here. Welcome to blockchain 2 whatever, and here is the hash. The hash here starts. Okay, let me make it. Is it clear? The hash starts with triple zeros. Okay. Let's change these contents. Welcome to AWS Riyadh user group. What happens? The signature is different. It's the wrong hash. Why?
Not start with 3 zeros.
Let's start with 3 zeros.
The encryption, maybe the encryption.
The nonsense.
The nonce is what?
You should know the nonce and get data, combine with and get the right hash.
Yes. When I started the default one, there was a nonce here for the data mentioned. Once I change the data, the existing nonce is invalid. Yes. It's not giving me the start 3 zeros, right? So I will click here in this icon. It's giving me a nonce. This is the nonce. So now the hash here is valid. Okay? Let's add another block. Append one block. Here data. For example, this is blockchain session. I will add new block. What will happen here? I have the previous hash. I'm using the previous hash, and this is the new hash. If you can see here, this is the nonce, okay? 2375. Now if I'll alter the data here and add like exclamation mark, so this block is invalid and the subsequent block will be invalid because now the signature is different and invalid, and actually the sequence block will be invalid as well. So I have to regenerate the new nonce for the first transaction, and as long as the hash, the previous hash is changed, the new one must have a new nonce. So I click here. It was 2375 already, I think. Now it's 2054.
The concept of nonce is not clear for me.
Okay. Okay. For example, if I have a string called Ahmed, Nadim, okay, and I'll try to get the signature, the digital signature of Ahmed, okay, it will give me one long characters, mixed random characters, okay. In the network, I need to agree on a pattern. Not anyone generate a signature, I will accept it in my network. I'll give a condition, okay. Any signature will be submitted in the network, it must start with 5 zeros. How can I accomplish these 5 zeros? Any signature, the signature changes according to its data, right? Ahmad generated one signature. If I want to change the signature, I have to append some data to Ahmad, exact, right? To get a different signature. If I want to make this condition, the signature must, the generated signature must start with 5 zeros. So I have to keep trying adding some random characters to the data, and every time I need to check the signature. Okay, start with 5 zeros? No, I need to change. Add different data again. Start with the 5 zeros? No. You got it? So these random data that I'm trying to append or add it to the existing data, this is the announce. So the last string that I will append to Ahmad to get the signature start with 5 zeros, this is the nonce. This is the right one. And this is the mining in the Bitcoin. All the nodes is trying to get the right nonce. So we'll have the correct signature. In Bitcoin, I think the condition is start with 10 zeros, which is much complicated.
Sometimes it's changed.
Yeah, based on the complexity of the network.
Ahmed, he sent it already in WhatsApp. I think the link is very clear.
Type, great. Thank you.
I think sometimes we are working with the same concept of the nodes with prevent replaying the web requests. Like we want to secure some APIs, so I will send like a node to prevent any hacker to trigger the request itself and try to replay the request to the server. Sometimes we using the nodes concept to secure this one.
It's like token.
Yes.
It's like token.
We combine the nodes, auto-generated nodes, with the head data to prevent replay.
This is the token in the web. Okay? Sure.
Suppose you have only 2 blocks in a chain, and you have 1 million blocks in a chain. So it is equally difficult to find a nonce in both the cases, or?
Now, based on the data that generated at the end, you are generating the nodes based on the content of the block.
Yeah, suppose the requirement is 10 zeros followed by something. So then it is equally difficult if you have 2 blocks or 2 million blocks.
No, I don't think so.
How is it different? Because it's all trial and error, right? So to find a hash that is followed by 10 zeros.
Again, still it's like whatever data you are getting, it's like a random characters.
Right.
Okay, you are keep trying to get the nonce, but the complexity, I'm not sure about it. I'm not sure whether it's equal or not. At the end, you have like a fixed length of characters.
Because I keep hearing mining Bitcoin will be more difficult day by day. Is that because
maybe the more transactions submitted, it's more difficult. Maybe it's irrelevant.
Because even though you find the correct condition, that particular hash key might be already used.
Yes, because it's based on a previous key, previous hash, if you remember. Okay. Any questions in this part? So we just understand now how the nonce is working, how the blockchain is connected. Okay, each block connected to the subsequent blocks. And you can try the site, I put it on the presentation, so you can go and play with it, start putting as much blocks as you can, and you can change whatever data will change. In the middle it will be invalid signature, and the subsequent block will all be invalid. Okay?
How is it difficult to hack this one as a general?
Actually, it's impossible to hack because you have to hack the whole blocks, the subsequent block. For example, if so far you might have 1,000 transactions in your network. These 1,000 transactions, you have copies equal, maybe we have here 40 people, we have 40 copies, okay, of these 1,000 transactions across all the members, all the nodes. So you as a hacker, you have to change your block and the subsequent block. Maybe, for example, you are in the block 70, okay, so you have to hack 900 something 30 transaction to be invalid because you change the data in one block, which means the signature is changing. So you have to change the rest of till the end of the block, and you'll try to replace these content across all these parts. This is why you so far you couldn't, you didn't hear about hacking for the Bitcoin network.
Till now.
It's not like till now. Theoretically, yes, you can hack. Practically, you need the power to all equals the power to the all people participated in the mining.
Now, so like quantum computer now, we don't know what's in the future when it comes to the idea. Till now, it is new technology and it is almost impossible, as you say. But it's future.
But that's what I'm saying. Okay, they might use like nuclear reactor to get some electricity power to hack the whole network. I don't know. Okay, so it's completely different because, as I told you, even for example in Bitcoin, people they waste electricity to generate these nonce, to solve this complex algorithm. If you want to hack, you need power equals to the powers that spent to get the whole network or the subsequent blocks, okay, that you need. And this is practically impossible. No one heard about Bitcoin hacking, and no one will hear about the Bitcoin, in my opinion. It's a very secure network.
Some records from Bitcoin have been disappeared
Sorry?
from the network. يعني some people will have the amount of Bitcoin and some disappeared. Is this case visible?
What do you mean by disappear? This is not possible because, yes.
I think he's referring to the exchange amount bits or something like that. I forgot the name, but lost 3 million Bitcoin.
Yes.
So there was theft of Bitcoin from an exchange. That's documented.
I don't know. Did this appear from the network?
Theft.
No, theft. Again, the transactions is there. The transaction are there in the network. However, who is owning these? Because the Bitcoin at the end it's a transaction, right?
But if you can track all the transactions, we should know who made
I didn't read about this case, but I'm thinking from the concept perspective. Everybody has a copy from the Bitcoin.
We should track the transaction and know who took it. But this is not the case.
What do you mean by who took it? There is an address, right? There is no address even for this one?
No, they didn't know who, how it disappeared.
It's different. Who or how? I don't know. Who or how? It's completely different.
If it's a theft, if I have 3 million Bitcoin, someone took this 3 million Bitcoin. If we are tracking the network the transaction details, we should know who took this.
No, not who. In the network, you have only public address. As we said, it's a privacy here. It leads the privacy, which means you are not availing your personal information on the internet. You are an address, public address, with like one address hashing like this. Sorry?
Even if it is public address or unusual.
No. Go to blockchain, bitcoin.com, and create your wallet, create your public address, and make it there. It's not linking to your personal information.
Do you know if someone in public address who represent me?
No, not public address, because guys, once you register in the Bitcoin, you will have two things: public address and public key and private key. The public address, it will be there for the general. It will be available to anyone in the network to receive your money or exchange money, trading, right? However, your wallet is protected with private key. This private key, once you register in Bitcoin, it will advise you don't keep the private key stored in your machine. Put it like on external USB memory or something, because this is the one you will decrypt your transactions, and you will try to identify your transactions. Yes?
So if you register with Coinbase, for example, you're giving them your private exchange?
You are not giving private key to anybody. You have an address, you send it to, if I want to exchange money with you, Bitcoin, I'll give you my public address. I'll give you my public address. Please transfer 10 Bitcoins to my public. That's it. So it will be in my wallet. Minus plus.
If someone gives a private key, lost.
Khalas, you will not be able to reach your wallet. Yes, you will not be able to. In this incident, how it's impossible to disappear, but it might happen because you didn't protect your assets, your coins. However, what I'm telling you, impossible to hack is the network itself. I can steal you whatever you have. If you have wallet, if you have a car, I can steal it in a way or another, right? But this doesn't mean that you are unable to identify. But it's moved from one entity to another entity. The theft has a public address, but you can't identify it. If you're the ransom that encrypt your disk, if you remember a couple of years back, he said for you this public address, please transfer for me $300, so I will decrypt back your data, right? They sent only the public key, the public address. no one able to identify, right? This is the downside of the Bitcoin, by the way.
If I send by mistake to
خلاص, it's gone.
public-
This is one of the problems. There is no central entity to raise fraud or do a complaint against. This is one of the main concerns for the banks and the financial ecosystem worldwide. You will not be able to fraud. You will not be able to complain about your coins theft or lost or whatever. No one will care. You have to protect your own assets. Any questions?
I think now it's all about these nodes because
Yes.
what I mean now, if someone successfully generates the nodes, what's preventing him to generate the next random nodes by adopting machine learning or something to follow the same sequence?
As I told you, it's like a very complicated stuff, and it needs lots of power. Again, if you will have like use a machine learning or something, it will consume power. Yani, at the end.
We will bring that forward.
Let's bring it if you will be able to succeed. Good,
Power is-
and give us the.
should be more expensive than
Yes, exactly. Some people there are a dedicated machine power supplies to do the Bitcoin mining. It's on Amazon. You can buy it and you can have built like a rack with maybe 10 or 20 of those small machines and start keep mining on it. But again, how it's feasible? Is it worth? Because the generated the electricity bill that you will pay, is it more or less than what you will get from this mining? This is the question. Okay, so is it clear so far? Okay. Blockchain values. Here the values that we have. It has a security, which means the blockchain itself, it's impossible to hack or to crack. It's a distributed and decentralized, so all the members in the same blockchain network has the same copy of the same transactions. So it's distributed, so it's a high available. If one member is down, still the network is running. Okay. Privacy, as we said, you are just eliminating your digital copy and you are exposing just the only public address of you. So you are anonymous. No one will try to identify your personality. As we said in the banking sector, this is one of the main concerns. Okay, so you don't know who is holding this wallet. Transparency and integrity. Transparency, you can create a network with people that you don't know, you don't trust. However, you can do business with them. You have the same copies of the transactions while exchanging any financial or any type of data. So at the end, you will have a visibility over your transactions. And the integrity as well. Trust, even if you don't have if you have like the blockchain network and even you don't know the person, the people who's participating, you're still able to submit your transaction, okay, and do your business, okay, and you are sure that these transactions are trusted because it's immutable. No one will be able to change your transaction, or we're still gaining trust on blockchain. Sorry. Here, blockchain use cases. In smart contracts, the rules and the penalties around specific agreement is the same way as traditional contract do. So if you have like the normal contract between two parties, it has terms and conditions, okay, and these conditions, once it's met, the transaction will be executed, right? Okay, if you are buying an apartment or something, you have a contract. Once you pay this amount of money, so the apartment will be yours, right? So this is the normal or the traditional type of contracts. In blockchain, you can do this in programmatically. One of the most usable or friendly smart contract framework is Ethereum. It's using a programming language called Solidity. You can start doing your programming, or you program your smart contract. Once the rules of these contracts met, the assets will be moved from one party to another party. Online purchasing, maybe music online, you are purchasing any e-commerce applications. So you can utilize the smart contract to get decentralized government. One of the use cases is voting. So as long as it's a decentralized in elections process, you can have like the voting, it's distributed across different hosts, which is your government or any areas within the same country or across the whole world. So you are pretty sure that the vote that will be submitted in the network, it's immutable. No one will be able to alter this. This is one of the use cases that you can use it. Notarization for civilians. If you have like a birth certificate, ID, education certificate, these stuff are constant by time. Yani if you have a birth certificate, you can get it. Maybe the e-government or the government will automate these parts, so you will have your all certificates. You can log into the system and they print it. It's immutable. Birth certificate is something not changed by time. ID not changing by time. Yes.
I think the birth certificate as an asset. I own it. Let's say it's a digital image, piece of information. How does that relate in terms of private copy and key? How does it work? Is it just like a Bitcoin?
No.
How do you treat it in terms of? I go to the government. How would they ID me through blockchain?
Based on the object. Exactly. This is a good question actually. How this birth certificate or these assets is related in a way or another to the blockchain concept. As we said that the blockchain has its own pillars or characteristics. One of it, we are relying here for these use cases in immutability. No one will be able to change it. So once I submit a birth certificate on my blockchain, what I need, I will not deal with it like an asset I need to exchange. I'm submitting the birth certificate, or it's like, for me, it's like a new transaction on the blockchain, because no one will be able to mess up with it. No one will be able to change it.
Digital identifier.
Exactly. It's a digital asset. No one will be able to change it. That's why I need to utilize blockchain for it. Not all the purpose that I'm using blockchain, it's only to be like a financial, to be reflected like a financial transaction. Okay? I might utilize blockchain because tracking or having immutable history of transaction, this is my ultimate goal.
I mean, I get the concept.
Yes.
The practical application. For example, we're in Saudi. Is there a blockchain that is owned by Egypt that when I go to a government agency, which blockchain am I on? My blockchain, the government's blockchain, whose blockchain am I submitting this digital asset to make this transaction? I mean, I know that
who is again, you need to identify the key players. Who is allowed to submit this birth certificate? For example, okay, take it like in Saudi Arabia. You have the government. The government have a Ministry of Interior, Ministry of Foreign Affairs, blah 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 blah. Okay, so the government will create one blockchain, and each ministry in the country will have a node. It's a member. So Ministry of Interior, which owns Abshir, she has a member. She will submit she will submit the birth certificate. You, as a client, will be able to access this birth certificate. You don't have a permission to add or modify or change any data in this blockchain. You are just a view only. Because again, we have different parties involved in the blockchain. So far we are talking about the authority or the nodes, the members of the blockchain who is eligible to submit transactions. We are not talking about how to view, who should view, who should. Okay.
Perfect. Let's walk through that. So I'm the client of the Ministry of Interior, and the Ministry of Interior is the only one that is allowed to upload my birth certificate.
Okay.
Now, the last thing I want is everybody that is a client to be able to view my birth certificate. In the US, they have your date of birth and your social security, they're you, they own you. So how do I interact securely as the client technically linked to this birth certificate?
This is away from you as a client. This is away, because Once the transaction submitted in the blockchain, it will avail it on our page for you. You don't know whether this certificate issued by a blockchain mechanism or manual or whatever the process has been used to publish this birth certificate. As an end user, you will not identify the technology. You got what I mean? I understand your question.
So if I go to the Ministry
What
of
is the type?
Education-
What is the type of transaction?
Let's say I go to the Ministry of Education, and I want to issue, renew my, I don't know, university degree.
It
They
is
say,
in-
who are you? We need to submit your birth certificate.
It is there.
It's, how do I interact with it? I give them the public key of that birth certificate. That is
As an end user, you are not interacting with the blockchain whatsoever. Because the asset already, once you born, you have the birth certificate and submit it in the network. If you have if you need an education certificate, it's already issued at the time of your graduation. It is there. You got what I mean? Whatever you are talking about, it's like a more to workflow and business process. Okay, management. If you need your education certificate, you need to upload your birth certificate and ID. This combination will trigger maybe a smart contract process from their side to show you the education certificate, not to create a new education certificate. Got it? So you as an end user, you don't have like a visible interaction as part of the blockchain between members, different parties who is eligible to interact with each other.
I saw this example in Saudi IT. Saudi company built an application for education certification with King Saud University. They create that you have mobile application, and this mobile application connected to blockchain. As what you said, your data submitted from King Saud University, and you have a permission. And if, let's say any company, if you for example, you go to the company and you want to work there, and in your CV you say I get a PhD from King Saud University. This company can connect to blockchain and ask to verify your certification.
That's exactly
okay?
right. So when I
And
have this mobile, how would they know this is my? How
okay,
can this
you will
has
just
anything back to me?
just wait, okay. And you will get in your mobile. This company requests you to see your details. Okay, and you can by touch ID or by some code to verify this company to see your details. They just send a request, and you own your data, and you will give this company to see the details. You know, this is the.
So you're kind of saying what I'm saying. That record that is on the node, that is associated with me, I have to have some sort of a mechanism to link back to it. A private key, for example, to go and say,
You have the
enter
private
this
key.
in.
The private key in your mobile.
I mean, at the end, you as a consumer or end user, you don't have like a real interaction with the blockchain as a cycle. It's subject to, it's different from entity to another. Because the way that you interact with Ministry of Interior is different than Ministry of Foreign Affairs.
I believe there is some confusion between blockchain as a technology and its implementation. I believe the confusion comes from Bitcoin. In Bitcoin, when you join, you are a node of the network.
Exactly, yes.
You are a node, so you can see the data, like edge and so on. In this example, the node is the government, and you are client to this government. You are client. You are not. You are as a member of any citizen. You are not member of this blockchain.
Yes,
You
this is
are
what I
client
mean.
to the government itself is a member of the.
Well, I understand. The node is the private governments own these 7 nodes. Okay, the 7 ministers, 7 nodes, they're the only ones allowed to put data in. The Ministry of Interior puts birth certificates. The Ministry of Education puts, but there has to be some linkage, right? Nobody's going to upload birth certificates for birth certificate's sake. They have to say that birth certificate is to this client somehow. You give some sort of an interaction. So like having technology for technology's sake.
You jump to a different level because the interaction between the ministries, as we said, because they are part of the network, they have their own communications. So they will submit your birth certificate or any government document, it will submit it to the blockchain network for verification, right? Regardless if it's a birth certificate, it's an ID, it's whatever. But your question that I understand, you as a client, how you're gonna interact with the blockchain. You are not actually a member, you are a consumer of the service. You are not part of the blockchain transactions itself, okay? Because each government will expose for you the services. Based on your entitlement, are you eligible to see this data or not? But this again subject to the ministry itself. It's not part of the network. That's what I mean. Okay.
How fast is the blockchain itself? You say that it's accessed only every 10 minutes.
No, this is for Bitcoin as an example. It's completely different for the other use cases. This is only for Bitcoin. Bitcoin is taking 10 minutes till it issue a new block. But this is not applicable to any other blockchain technology. It will immediately
once you given the operation that we have for this nonce and the verification operation itself, it seems that also it's not fast enough for maybe the application that needs.
Okay. Look, the nonce mechanism, it's different, and the consensus algorithm is different from application to another application. Okay, because in the business, in the cryptocurrency, it's a must to have this nonce and do these complex stuff to get incentive with money. However, in the business network, you might don't need to do like this mining stuff, because under the hood, you're not at the end, you are not creating your own algorithm to run the blockchain. You are utilizing existing frameworks to run your network or to build your network. And they underneath, they have their own different technologies. Not exactly to be like not to be the nonce, maybe the digital certificates that will, it's different, like authorization and authentication mechanism, not necessarily to have the nonce. I just mention it to people are familiar with Bitcoin.
Yes, this is right. Bitcoin is one of
yes, exactly, one of the use. But don't take all the implementation and technology used in Bitcoin end to end as a base to build your blockchain network. No, it's not the case. And that's what AWS did. Will come in the next slide. We have use cases for banking, like the central bank. It has like central bank, and we have all the banks in the kingdoms. And instead of every day you have a reconciliation process and settlement, for example, between the banks and each other and the merchant, or in the e-commerce area specifically. Sorry?
International transfer.
Even international transfers. You are eliminating here the intermediary people, because if you want to do transfer across the border, you have to send from your bank to a correspondent bank, and this correspondent bank will take his cut until he send the money to your beneficiary. Okay, so it has a cost. For example, in Bitcoin, if you want to do this transaction, you directly doing from one wallet to another wallet, no intermediary entities, which means it's cheaper. You don't pay for these transactions, right? So this is one of the use cases in the banks. Healthcare, by the way, at all these use cases, it has its own challenges. That's why Bitcoin is blockchain is not widely adopted in these areas, because it has its own challenge. In the banking, you need I need to know what are the governance will control these transactions. How can I identify people who's acting on this and on my network if I'll avail it to the public, and a lot of challenges. Even healthcare as well, for privacy and patient records, how we can share it in a way or another with the trusted parties like Ministry of Health and the other medical institutions in the country. Are they eligible to see the patient history or not? Because in healthcare you have the HIPAA standards and patient privacies and all this stuff. Okay, real estate, the most popular use case to tracking, maybe for buy land or buying maybe apartment or whatever. So for one asset, you will be able to track the history of these assets. I think this will like eliminate the cases, the judgmental cases or legal problems. Okay, because now, okay, if I'm a government and I am adapting the blockchain to trace all the assets, I'm documenting all the assets or the real estate entities. So I have a history. This land moved from this person to another person to blah blah, whole history of this asset. Blockchain in AWS. Quickly, in a couple of minutes, and we'll finish, inshallah. How blockchain in AWS, how AWS look like, it utilize these services, used to solve two types of customer needs. As we know that AWS is starting from the customer and work backwards, okay? So in their research and talking to the customer, they found two types of models, of use cases. One case is a centralized one. So people are happy with their centralized database. However, they are facing some difficulties to have audit trail for their stuff, so they have to code it and do it manually. They have a challenge in securing the historical data. Okay, so anyone has access to the database, will be able to change the data easily, which is another challenge to them. So in this case, they have the first case, multiple parties work with a centralized database. So we have a centralized database, different parties dealing with this database. However, maybe is using MySQL or SQL database to have